And today we're going to cover two types of triangles, and these are called special right triangles. Two special right triangles. And they're special right triangles because they have rules that relate the side lengths to one another. Whereas you don't have to use the Pythagorean theorem to find missing side lengths. All right? The first type of triangle is a 45, 45, 90. Now, you're going to see some different pictures of a 45, 45, 90, and you're going to have to be able to look at the picture and realize that it is a special right triangle based on the picture. This is one example of a 45, 45, 90. It's got one 90-degree angle, and it's got two sides that are equal to each other. This triangle is a 45, 45, 90. You'll see this diagram. That is also a 45, 45, 90. Because in a right triangle, if one of the angles is 45 degrees, the other one has to be 45 degrees. If the two angles that are 45 degrees, if you have two angles in a right triangle that are 45 degrees, then the sides are also equal to each other. This is another picture. This diagram is a 45, 45, 90 because it's a right triangle and both of the sides are the same, aren't they? Aren't these two the same picture?
Yeah, there's one split.
The tick marks tell you that the two legs are congruent, and if both legs are labeled X, then they're congruent to each other. Okay? So those are three different pictures of 45, 45, 90 triangles. They all have the same properties. Okay? Excuse me?
How do you know those are congruent, X and X?
Because I just labeled them, Jordan. I just labeled them as X. If they're both labeled X, then they're equal to each other.
What if the other one's labeled Y?
Then they're not equal to each other.
Oh.
So the 45, 45, 90s have a rule. And here's what the rule looks like mathematically. If this angle's 45 degrees and this angle's 90, and this side is X, then this side, well, let's call it L. If this leg is L and it's a 45, 45, 90, then this leg is also L. And the hypotenuse in this triangle will be L times the square root of 2. So here's the rule for this type of triangle. The rule for a 45, 45, 90. If given the length of a leg multiply it by the square root of 2 to find the hypotenuse. And that's what this picture means. That if the two legs are labeled L and the hypotenuse is labeled L times the square root of 2, it means if you're given the length of a leg multiply it by the square root of 2 to find the length of the hypotenuse. If given the hypotenuse, divide it by the square root of 2 to find the length of the leg. Those are the only two situations in a 45, 45, 90. You're either going to be given a leg and asked to find the hypotenuse, or you're going to be given the hypotenuse and asked to find a leg. So if you're given this triangle, and you're asked to find x, in this case you are given a leg and you're asked to find the hypotenuse. So you multiply 7 by the square root of 2. Now, in simplest radical form, this answer is going to be 7 times square root of 2. That's it. If you have to turn it into a decimal, then just multiply 7 times the square root of 2.
That's the answer in radical form.
That's the answer in radical form, yes.
So that's pretty much our answer. If it asks for, unless it asks for it in its simplest form.
If they ask for it in simplest radical form, that's it. You're done. If you're given the hypotenuse, this is a little bit trickier, but there's two ways you can do it. So if you're given this picture and you're told that the legs are both x, and this hypotenuse is 3, what type of triangle is this?
Oh, right.
It's a 45, 45, 90, isn't it? And you're given the hypotenuse, and you're asked to find a leg. In simplest radical form, what you would do is you would take 3 and you would divide it by the square root of 2. When you're in radical form, it's not considered simplified if there's a radical in the denominator. And there's a step called rationalizing the denominator that you have to do. Whenever there's a radical in the denominator, you multiply the numerator and the denominator by whatever this is. Here's what happens. In the numerator, you get 3 times the square root of 2. And in the denominator, you get the square root of 2 times the square root of 2, which is the square root of 4. This simplifies to 3 times the square root of 2 over, what's the square root of 4? 2. So this is the length of one of the legs. Now, that's it in simplest radical form. If you would have taken 3 and divided it by the square root of 2 to begin with, do it in your calculator. Do you get 2.12? Okay, so this is 2.12, isn't it? Now, take this and type it into your calculator. 3 times the square root of 2 divided by 2. and you're going to get 2.12. So do you see how it works both ways? If you can't pick up on this rational form pretty quickly, then just keep this as your answer, type it into your calculator, convert it to a decimal. And then when you're taking the quiz or doing the study guide, you'll just take each of the answer choices and convert them to decimals. And then you'll match. Okay? Yes?
Wait, so we can do either of these?
Yes.
Okay, and then I don't get like, so on the last one, how did you get 7? It was just part of the problem?
Yes.
Oh,
When I'm setting a calculator to 3, I got 4 point.
Okay, so we've done one where you were given the hypotenuse, and we've done one where you were given the leg. So, turn the page. And now we're going to talk about a 30, 60, 90 right triangle and its rules. A 30, 60, 90 right triangle obviously has a 30, 60, and 90 degree angle. So if you're given a picture of a right triangle and one of the angles is labeled 30 degrees, the other angle has to be 60, doesn't it? Because the three of them have to sum 180. Here's the rule. The side across from the smallest angle, all right, is the shortest side of the triangle. So if this angle is 30, then this angle is 60. This side down here on the bottom is called the short leg. The hypotenuse in a 30, 60, 90 is always 2 times the short leg. The long leg in a 30, 60, 90 is always the short leg times the square root of 3. That's the relationship. So if you are given the short leg, multiply by 2, to find the hypotenuse. And by square root of 3 to find the long leg. If you're given the short leg, that's the side that is opposite the 30 degree angle. You multiply the short leg by 2 to get the hypotenuse. You multiply the short leg by the square root of 3 to get the long leg. Given the hypotenuse, divide by 2. To find the short leg. So if you're given the hypotenuse, all you do is you take the hypotenuse, you divide it by 2, and that's the length of the short leg. Given the long leg, Divide by square root of 3 to find the short leg.
What, divide by the square root of 2 or divide by 2?
What does it say right there?
2.
Okay. Has everybody got that? Good? All right, so look at example 3A on 370. And this angle up here is 30 degrees, so this is a 30, 60, 90. You're given the hypotenuse, and you're asked to find the short leg and the long leg. So what's the value of x going to be equal to? It's 8, right? 16 divided by 2 is 8. And now you know the short leg. If you know the short leg, how do you find the long leg? Multiply it by the square root of 3. So this would be, in simplest radical form, 8 square root of 3. In this case, what are you given?
The short leg.
You're given the short leg. So let's find, what's the value of x going to be equal to? 5 times square root of 3. And what's y going to be equal to? 10. Does that make sense? It's two triangles, a 45, 45, 90 with its set of rules, and 30, 60, 90 with its set of rules. And all you just have to do is look at your notes and look at the rule. Okay? Short side to hypotenuse, multiply by 2. Short side to long side, multiply by the square root of 3. If you had to multiply by the square root of 3 to go from short side to long side, then from long side back to short side, just do the opposite, right? Divide by the square root of 3. And if you know the hypotenuse, you divide by 2 to get the short side. Questions? Your assignment for today is on page 372. 1 through 3. Actually, just make that 1 through 7. And then 9 through 15.